The natural, logarithm function.
And, all right, so when you started these logs in 10th grade, and of course we're going to go faster than y'all did then because we don't need all the little parts of it. We just need the basics. But y'all talked about two different types of logs. You talked about common logs, which are base 10, and you talked about natural logs, they're base E. Those are the two types that you talk about. So before we get on into this other, let me add a little bit up here for you. A common log with a base 10, an exponent form of this might look like, here's the exponent form. Might be like 10 to the third, something like that. Sometimes, I mean, I could even finish the statement. 10 to the third equals that. That's the exponential. The log statement for that same thing would be written log base 10 of 1,000 equals 3. And I'm writing this out here to remind you, you know on the exponential form, 10 is the base, 3 is the exponent, 1,000 is the power.
So we're basically just doing it opposite.
You make the little circle, and if y'all remember, you go base to this when you write it in log form. So it's log base 10 of this equals this. It makes the circle. So that's how you probably learned it with this second hour. Now, let me remind you too, I like logs. I don't know why I've always liked logs, but most people don't. Logs are the opposite of exponents. They're very connected. So if you're good with exponent rules, logs kind of go with that. So if you want to think about it like this, if I'm looking at it in exponent form, the inverse of it is going to be like this. Okay, so now let me show you as a natural log. A natural log may look like something like this. That might be the exponent form. And the log form, ln, as they would call it for natural log, you do the same thing you did just a second ago. You would do the little circle when you rewrite it, except instead of saying log, you're going to say ln for natural. So you would do ln of e 8 equals 3. So you make the same little loop, this to this to this, to get you there. So that's just notation. That's just how it writes. Does that ring bells that much?
I never really learned that.
You never really learned it?
No.
All right. So all I've said now is if you're in exponent form, if you're in log form, that's just your form. Base 10, base E. Here's another thing. When I base 10, I usually don't even show this little 10. So in other words, I could have written that and it would be an understood 10. But only when that happens it'll be 10. Nothing else. It could be a base 2 or whatever. So that is an understood 10. I could have written this one, ln 8 equals 3. That is an understood E right there, always for ln, okay? So if you ever see that. Now you can have other bases here. These are always going to be base E. These are always base E. Well, I take that back. We might get into some solving where they make it something else. But you can have other bases. You just do. Put it where it goes. Okay. All right, so I don't know why I've got that there, but E is a positive real number such that ln of E. Okay, let me think about this just a minute. All right, let's just a minute go with this. This is obviously in the log form. Let's take it out of log form, see what it says. If you take it out of log form, you still do the same little loop. So if I was reversing this,
Well, that's some good stuff right there.
yeah,
It's just on video.
Can I show it?
yeah, show them what's happening outside.
I wonder how it looks in Japan.
It looks.
I think it's freezing rain.
It does.
Wait, hold on. What is the temperature? And then we'll know.
All right, no, quietly check that. Let me keep going here, because they're watching. Okay. All right, listen. All right, y'all with me now?
Yes.
Let's undo this. Write this in exponent form.
Is that the base or equals?
It's understood that there's a base in
There's
two.
two E's.
Right, so that's understood. Okay, so this would be, this, that makes sense. That makes sense. E to the first equals E. Okay, so
Well, of course.
provided,
Yeah, that makes
yes, okay. So we know how to read that then. All right, don't worry, we're still gonna do stuff with this. Okay. We're getting basics. All right. Here's some properties that we just need to know. First of all, hold on the properties. Let me show you what the picture of it looks like, okay? Let me show you the picture of LN.
This,
yeah.
Yeah, and then we'll come back to properties. It'll make better sense. All right, so this is the graph of Ln of x. All right, so let me ask you this. Just pretend for just a minute. What if I wanted to do, I'm gonna rewrite, follow me just a minute. If I rewrote this, rewrite that in exponent form. Just like it is. What's my base? E, that's understood little e. E to the
Y
y,
equals X.
yes. All right. So follow me for just a minute here. What if I said e to the 0? What would that equal?
0. 1.
Anything to the 0 is 1. So you've just given me a point on this graph. What point can I take from that?
1, 0.
X was 1 and y was 0. Okay. So we have the point 1, 0 on here. Interesting. All right. Here's how this picture goes from there. It curves up and it curves towards the axis, never to cross. So it kind of goes on an upward curve. This curves closer and closer to the y, never to cross. So when you draw this, you know you always got a point right here on the parent, and it's something like this. Now, if I type in the calculator, you don't have this on yours, but let me show you on the calculator. There it was. See,
What'd you type in?
I typed in, well, that's a saved picture, sorry. I typed in that. I just typed in Ln of x, and it shows me that. Now, if I was going to take this graph, if I was going to take this, and if I wanted to shift it, I'm getting rid of this extra gunk here. If I wanted to shift that graph, just, you don't even have to copy, just think with me. If I went like this, try that again. Yeah. What would that be? Y equals, right. And they might do that around it just to show that it's not, you know. What if I wanted to shift it from here? What if I wanted to shift it? That's ugly. Yeah, I got you. Hang on, let me fix this. Alright, let me fix this better. Alright, so that would be y equals ln x. Right, because in parentheses, when it happens, it's left. So these are just your little parent graph shifts that I'm talking about doing to this thing. So you can make any of those little shifts. So my point is, your parent graph crosses at 1, 0. Yes. But there are things that can occur that's gonna move it, you know. So just, you know, there's a parent graph for us. That's all we need. All right. So thinking on the parent graph, we'll go back to those properties then. All right, let me ask you before you fill in the properties actually. What would you say the domain is of the parent, the red one?
Domain.
0.
0 to infinity, because
Never passes.
it never goes past here, but it goes forever there. So domain 0 to infinity. I'm gonna flip back in just a second. What's the range? Yes, because it's forever down and forever up.
Does it not approach a certain Y value?
No, if I drew it that way, I don't. It's gonna steadily go.
Okay.
It's not curving off like that, but it's a good question. All right, so we said domain and range, yes, okay. Other things they point out about this is continuous, yes, we see that. It's increasing, and it's 1 to 1. 1 to 1 means it's a function. It's a function. It passed the vertical line test. That's their way of saying for every x there's a y. 1 y, no more than 1. So that's all that means. And notice the graph is concave down. Since we just recently talked about concavity, the graph is all concave down. All right, so that's just some properties of that picture. All right. So then we're still, again, just stuff. Now we need to talk about properties, log properties. This is not calculus. This is 10th grade, second hour. This is just going through it quicker. All right? So we're just going to talk about the log properties for just a minute. All right, let me cover up some of this so we can talk it one at a time. All right, ln of 1 is 0. I think we just proved that a minute ago when we rewrote it. If you ever have to stop and think about it, that's what I do. If I ever have to stop and think about it, I remind myself there's a little e there. So e to the 0 is 1. So there, yes, that makes sense. Here's why I have to do that sometimes. Sometimes I forget if the ln of 1 is 0 or if the ln of 0 is 1. I think which way. So then I go and do that and it tells me. All right. Now, let me ask you this. I told you a minute ago that logs are opposites of exponents, kinda. On the exponent rules, if I was multiplying like bases, what would you do with the exponents?
What?
You'd add. Multiply like bases, you add exponents. Log rule is, if I'm taking the log of a product, then I can rewrite that as addition. That is the connection. You can kind of see the connection to the exponents. So if I'm taking the log of a product, I can rewrite that. Why would I do that? Because it may be easier to solve through the problem. Don't do it if it's not, I mean, you know. All right. Here's the rule for exponents. Just like if I'm taking the log of a power here, notice what the exponent does. It drops down in front. And when it drops down in front, it's a normal. It's not an exponent. It drops down as a normal number. So if I need to rewrite log of a power, I'll drop that down. Why would I do that? Because it may be easier to solve this than this. All right? And here's the last one that we really would ever use is division. Just like with the exponents, see the connection. With exponents, division means subtract. Same thing here. And while we're at it, I didn't have it on here, but while we're at it, I'm going to list the exponent properties over here just real quick, because they're quick anyway. Just because. So we said x to the a times x to the b would equal x to the a plus b. So these are the old middle school would have been where you'd have done these. But I'm still gonna remind ourselves.
Thank you.
All right, you're welcome. X to the a raised to the b. See if you remember what happens with that.
Multiply.
Multiply, right. X to the a times b, right. X to the a divided by x to the b minus x to the a minus b. And the only other one I think I need to throw in here is x to the 0 equals 1. Yes. So these are the ones we care about, and these are the logs we care about. You know, when y'all learned those way back when, y'all did a lot of tricks with them and got into the harder problems. We don't care about that so much. We just care that we remember those properties, and we can remember how to use these properties too. All right. So a little bit more. I will remind you how to expand. This is still Beckenauer stuff. We want to expand a log. Why we would do this? We can write it out in an expanded form, and it makes it easier to solve, and you can use your properties and that kind of thing. Okay. So, using these properties back here, y'all, using these properties, we're going to rewrite this. Okay? So if I was going to rewrite the ln of 5 divided by 2, look back at the property for division. All right, so how would I rewrite?
ln of 5 minus ln of 2.
And I'm going to try to put parentheses around just because I don't usually, you don't have to. The only reason I would say sometimes they do is so that they don't think it's ln of 5 minus blah, blah, blah. It's just ln of 5 minus ln of 2. Okay. Now, we're going to expand this next one. Before we expand it, though, we're going to rewrite it because that's going to be
To the 1/2.
to the 1/2 would be easier to look at this. So let's call that, instead of what we got, let's call it ln 4x plus 1 to the 1/2. Be easier to expand that. All right. So we've got, what'd you say?
1/2 ln 4x plus 1.
All right. Very good. And then that would probably be easier to solve if we needed to, I'm sure. All right. What about on C?
Same thing as A.
Kind of. A little bit different. What's different? This right here. So when we expand this, I'm going to have ln. What do you think?
Multiplication?
Yes. 7 plus ln. Here's another thing. Notice every time I change my operation, I need to say ln again when I expand. So I got ln of 7 plus, because it was time, ln of x.
Is that all in parentheses?
All in parentheses.
That's what else, all in parentheses?
All divided by
Minus.
Okay.
Minus.
ln of
You would
6.
do minus ln of 6, and to answer your question, no, if it's anything on the bottom, you'll just say minus it. You won't have to,
You don't have to put.
you don't have to put, I know that's weird, I know. But anything on the bottom, you just say and minus and minus and minus.
But if you had two things on the bottom.
Then you would do at minus again. So like if I had a y on the bottom, then I would have had and minus lny. I know that's
I
awkward.
mean, technically you could do minus all of it, log of.
But then on the
Actual
next
log.
step, you would
You just
actually
have to distribute that.
it distribute too. Yeah, I know, it's kind of odd. All right, so that's expanded.
Oh, Lord.
All right, look at this beauty here. Believe it or not, my Reg Ed juniors do this on their next objective. They'll do these big expansion ones. So once you kind of get used to it, it's not as bad. All right, so do it.
Is it 2 ln x squared plus 3 minus 3 ln x plus x squared plus 1.
Close. It's not 3. Look at it.
Oh,
You know
Good
that.
job, Tim, you.
Okay. Alright, okay,
1/3 ln x
Yes.
squared plus.
yes. Okay, we're gonna, y'all will always start on top
Write that down.
and then go to the bottom. Alright, start on top.
Okay.
We got ln, wait, you tell me. 2 ln of x. Wait.
Wait, but there's two.
Yeah, hold on. Hold on.
We got a foil.
Well, hang on. I think we could say, here's what we do. 2 ln x squared plus 3. Here's why I'm telling this. I'm treating that like that's my base thing right there for now, okay? All right, because look at how we did B.
Yeah.
That's how we treated it. Okay. All right. My brain starts thinking too deep here. All right. Then I'm going to say minus. And then what? ln of x.
Because
Oh, that's
the
it.
cube
I
root.
thought it was like an X one.
Minus.
Yeah, I did that.
That's actually x times
Cube root.
this.
Yeah, that.
This is x times all of this to the 1/3.
Yeah.
So that would be
And then we do
Plus
minus.
1/3.
minus 1/3. Because minus means it's still on the bottom. That's all that means to us.
Times x squared plus
ln.
ln.
I know. That's it. That's the answer.
That's all.
Okay. Minus everything that happens to be on the bottom. And go ahead.
So it'd be minus even though the bottoms multiply together.
Yes. But here's what would happen. Here's what would have happened. We could have shown all this as multiply and then distributed, and it would have ended up like this. The negative would have distributed. Yeah. So really everything that's on bottom, you just need to show it as a minus in front of it. Okay, so let me see where we're at. I think that is everything for us today.